Hey guys, we are going to talk about one of my favorite topics today, systems of equations. We're only going to focus on linear equations today, and we're going to use two methods. We're going to use substitution and graphing. There is a third method called elimination, but for today, we're only going to look at substitution and graphing. I love working on these because they're like fun little puzzles. I think they're so much fun. Okay, so a system means multiple. So like if we have 4x plus 3y equals negative 8, and then we also have negative 8x plus y equals negative 12, this is a system. They go together. They're going to be on the same graph. They go together. Oops. And they would be on the same graph. Okay? So they work together. That makes them a system. So our question is, in the system, what is x? We're looking for an x and a y that works for both. Works for both. Okay. Oops, that's not how you spell both. So our goal in this system is to find something that makes both of them true. So we need an x and a y. So what x is out there that I can put in here, and what y can I put in here and make both of these work? Make this side negative 8 to equal negative 8, and make this side negative 12 to equal this negative 12. So the first method we're going to look at is called substitution. So we're going to look at substitution. Oops. Substitution. Okay, and as you can guess, when we use substitution, that means we're going to substitute something in. So what we do first is we look at each term. So there's 6 terms total here. And I'm going to see if any of those terms has a coefficient of 1. And if it does, that's going to be my target. Right here. This y has a coefficient of 1. So I'm going to target this y. I am going to turn this y, I'm going to rearrange this problem to solve for y. So if I do that, I'm going to have y equals 8x minus 12. All right? So do you see how I've done nothing but just rearrange this to this? So now how I've solved this for an individual variable, it does not matter if it's x or y. I'm going to take it and I'm going to substitute it in for the y of the other variable because they have to be the same. And watch the magic that occurs when I do that. When I do that, I'm going to have 4x plus 3y. Well, I just said that y is 8x minus 12 equals negative 8. So do you see how I substituted my y into y? Because they're a system, they have to work together. Let me give myself a little more room. So now, if you look really carefully at this, in this new equation, all I have are x's. See, there's only x's here. And as long as I have one variable, I can solve for it. So I'm going to rearrange this whole thing and get x. So I'm going to have 4x plus 24x minus 36 equals negative 8. 4x plus 24x is 28x. 36, negative 8 plus 36 is 28. So 28x equals 28. Divide out my 28 and look at that. What does x equal? X equals 1. Okay, so now I've figured this out. So x equals 1. Well, now if I have x, can't I substitute my x back in? Let me choose a different color. Can I substitute my x back in? And then I would be able to solve for y. So now I'm going to do that. I'm going to take my 4x plus 3y. I can take either one, actually. I'm just going to take that one. I'm going to put my x in. I just figured out that x is 1. Plus 3y equals negative 8. And again, I only have a y. Now I'm back at one variable. So now I can solve for this y. So I'm like, okay, this is 4. This is 4. 4 plus 3y equals negative 8. I'm going to move my 4 over. I'll keep running out of space here. And I'm going to have 3y equals negative 12. And I'm going to divide out my 3. And I'm going to find out that y equals negative 4. And then I'm going to say, okay, y equals negative 4. Y equals negative 4. And now I have found an x and a y that should work in both of these linear equations that are part of the system. So I'm going to go try that. I'm going to come over here. I'm going to make this small. I'm going to come over here and I'm going to check my work and show it to you that this works. So I'm going to check that I've got 4x plus 3y equals negative 8, and I have negative 8x plus y equals negative 12. And I'm going to substitute in here x equals 1 and y equals negative 4, and I'm going to put them in for both. Okay, so I'm going to have 4 times 1 plus 3 times negative 4. And that should equal negative 8. 4 minus 12 equals negative 8. Negative 8 equals negative 8. Check. That works. On this one, I'm going to have negative 8 times 1 plus negative 4 equals negative 12. Negative 8 minus 4, negative 12. Check. So my answers work. Wow, this looks pretty messy. Okay, so here's what happened. Let me recap. Let me make this bigger. Let's recap what we did. We rearranged to solve for y. We chose this one because it had a coefficient of 1. If it didn't have a coefficient of 1, we would have rearranged and just the same process and just gone farther to get there. Then we plugged it in to the other equation. You have to plug it into the other one. So then we plugged it into the other equation, and that gave us only x's. Then we were able to solve for x. After we had x, we plugged it in, and then we could solve for y, because all we had in the next equation was a y. So we were able to solve for y. So we found an x and a y that worked for both. Let's try another one. Let's try one that maybe isn't quite as nice. Okay, let's try this. You'll see this happen a lot. So again, we're going to use substitution here. So 7x plus 3y equals 22. And then we're going to say 4y equals 20. Okay, well, this one doesn't even have an x. So remember, our goal is to get a variable alone. Well, clearly this bottom one is the way to go because we can isolate this y really fast. So if I rewrite this one, I'm going to divide out my 4, and I'm going to get y equals 5. Okay, so now I know that y equals 5, and I'm going to go, remember, substitute that in to the other problem, or the other equation. So that's going to be 7x plus 3y, well, y is 5, equals 22. And look, here I am again. I only have an x now, which is great. That means I can solve for x. So now I have 7x plus 15 equals 22. So 7x equals 7. X equals 1. Wow, I keep giving you really nice numbers. Okay, boom, look at that. Done. That one was so quick. We already had y. We were able to find that immediately, and here's our x. And we're done. Let's try one more. Okay, let's say we have negative x plus 5y equals negative 16, and negative 3x plus 7y equals negative 8. If you want to pause right now and try and solve this guy, I think you should. Okay, let's see. Which one do you feel like is the best variable to isolate? I'm going to vote for this x. It just looks easy. So I'm going to rewrite this one. And then I'm going to have negative x equals negative 5y minus 16. I need to divide out this negative 1, right? And that's going to give me x equals 5y plus 16. So I'm still working with this, and now I'm working with this, and this time I know what x is. So I'm going to take that, and I'm going to plug it in to x. So that's going to give me negative 3x. Well, x is 5y plus 16 plus 7y equals negative 8. Look carefully, all I have are y's, so therefore I can solve for y. So I'm going to work this out. Negative 15y minus, what's 3 times 16? 48. Minus 48 plus 7y minus equals negative 8. I'm going to get my y's together. See my y's? Leave those together. Negative 15y plus 7y is negative 8y. I'm going to move my 48 over there. Negative 8 plus 48 is 40. Divide out my negative 8, and y equals negative 5. Okay, so step 1, done. I have y. Now I'm going to plug my y into either one of my original functions. Doesn't matter which one. I'm going to go with the top one. It looks like maybe it's a little nicer. Okay, so I'm going to put my y in here. So I'm going to start a new little space here. So I'm going to this time say negative x plus 5y, and y I know is negative 5 equals negative 16. So negative x minus 25 equals negative 16. Negative x equals negative 16 plus 25 sounds like 9. 9. So x equals negative 9. And boom, we're done. Okay, now, do you remember at the beginning of this how I explained that we were looking for an x and a y that work for both of them? And it's true. It's a variable, it's a value that makes both of these true. But what it also is a coordinate. So I can take both of these and really make them a coordinate because I have an x and a y. So negative 9, negative 5. So it's a coordinate, like on a graph. That's right. So our next method for solving this is by graphing. And here you'll really see where the coordinates come to life. So we just talked about substitution. Now we're going to talk about graphing and what this looks like to solve by graphing. So here's our graph. I hope it's big enough. You know it probably isn't. All right, so here's our system. Y equals 4x plus 3, and y equals negative x minus 2. And look at this. They already set these up, so substitution would be really easy to do. But unfortunately, that's not your job. Our goal is to solve these by graphing, which means we're going to graph these independently, and then we're going to see where they cross, and that's going to be our answer. So let's have like a purple one and a green one. Okay, let's start with purple. So y equals 4x plus 3. So my y-intercept's at 3. I have a slope of 4 over 1, and it's positive. So 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. All right, so here's our line. Okay, and then let's look at our green line, and it's y equals negative x minus 2. So my y-intercept's at negative 2, and this is going to be a negative slope of 1 over 1. Oh, I already see where it's going to cross. So it's doing this. And you can see here, where did it cross? It crossed right here at negative 1, negative 1. And boom, answer. This is our solution. So, and this is actually just what we had before. X equals negative 1, y equals negative 1. We're just writing it in coordinate form, and coordinate form makes a lot more sense when you're dealing with a graph, but even when you're dealing with substitution, it's the same. So as a quick recap, let's go through this whole situation again. So we're dealing with systems, and we're dealing with two methods, and those two methods are substitution, I can't spell, substitution, and graphing, okay? And in substitution, you isolate a variable. Remember, we would like solve for y. It doesn't matter which variable you isolate. And you sub back into the other equation. To other equation. And then you solve. And then you plug in again, right? Plug in and solve the other variable. So those were your steps. Okay? And in graphing, what did we do in graphing? In graphing, we graph both lines, and you find the intersection. All right? And that's it. That's how you solve a system of equations. Your answer should always be an x and a y as your answer. All right, good luck.